Good morning to everyone and welcome to our user training webinar today. My name is Emma Nyköri. I'm Climix Training Manager and I'm here with Panu Vilska, our CEO.
Yes, hello everybody and welcome to our training webinar on my behalf as well. So today on our agenda is how to set up and configure the Climix VCS 100 CR series, the new model, together with the main unit, the master unit, and the extension unit, and an optional catalytic converter. So we will go through step by step how the system is set up, how it's programmed, and then we're also going to discuss some use cases. And Emma will guide you through the setup process. And during the presentations and during this webinar, you have an opportunity to make questions through the chat wall. And we have also some people in the audience who can also make live audio questions. So again, welcome everybody. And Emma, let's start by explaining what exactly we have here.
Yes. Okay. So here we have the Climix VCS CR extension unit. And over there we have the master unit VCS 100 CR decontamination units. And then we have all of the accessories for these. As you can see, the turquoise color catalytic converter and Vaisala sensor for the units, both. Then we have the hydrogen peroxide bottles here, and also the suction hoses set for the bottles. And we will go through the all the necessary things and how to use the device and set up a bit later. Can I see the decks, please? So today we are going through this Climix 5-step training program that we have. Next slide, please. Today we are going through how to handle safely hydrogen peroxide solution. Then we are also talking about the decontamination process in general. Also the testing and validation, how we can know what is the result of the decontamination process and how to validate it. Then we are gonna go through some use cases and then to the hands-on learning session. Next slide. So, about safe handling of hydrogen peroxide solution. What it contains, what we need to know. We need to know the properties of hydrogen peroxide, how to storage it, and how to handle it safely, and of course the occupational safety when doing the decontamination processes. A bit about hydrogen peroxide solution. It is also known as dioxidane, oxydanol, perhydroxide, acid, and dihydrogen dioxide. Its molecular formula is H2O2, which is quite close to water actually. Its density is 1.2 grams per 1 cubic centimeter, and its melting point is 52 minus degrees, and its boiling point is 100 Celsius degrees. Next slide, please. So, hydrogen peroxide, it is a clear liquid with a distinct odor, and it is highly oxidizing. It decomposes in the presence of light and heat to form of water and oxygen. The decomposition is catalyzed by various compounds, including metals, for example, iron, copper, zinc, chrome, nickel, and different impurities. And these are actually things that you need to consider when planning the decontamination process. And because it's instability of the hydrogen peroxide solution, it is typically stored with stabilizers so that the solution is safe to store. It is potentially hazardous when it's inhaled, and it is hazardous if swallowed. So, how we storage the hydrogen peroxide solution safely? The storing should be done always in a cool, ventilated and light-protected place, kept away from flammable and organic matter. How do you, Panu, storage the hydrogen peroxide solution? Where do you keep it?
Well, it's typically in a separate cold, well, it doesn't need to be cold, but cool storage room. So something that you can compare to a wine cellar.
Yeah.
I guess the good rule of thumb is that if you would store there wine or beer, that's good conditions for hydrogen peroxide. Now, it was mentioned that it decomposes when exposed to light. So some people have asked that why then we have transparent bottles. Well, the reason is very simple. Typically, these bottles are consumed in a quite short time, and what is more important than the long-term storage of these particular bottles, we can see how much liquid we have in the bottle. So the larger volume containers that we deliver and what our suppliers provide, they are naturally made of either dark blue or black plastic. Normally, when you handle these bottles, it's always recommended to use protective gloves, nitrile or latex gloves. Now, for this particular training session, these bottles are filled with water. So if you wonder how we handle this in a, how would I say, a little bit careless way, is that these contain only just normal water for this training session purposes.
Yes.
How do you recognize that the bottle has water is that there is no sticker. The bottles that we deliver with hydrogen peroxide, they have the applicable stickers.
Yes. So, about the storing, so it should be light protected and cool place, and Panu had a great idea, a thumb rule for the storing of hydrogen peroxide solution. Of course, you should always remember that mixing up with organic compounds such as alcohols, acetones and fuels creates potential risk of fire or explosion. So always keep that in a safe place away from those kind of materials. How do we handle the hydrogen peroxide solution safely? Well, first things first, in case of a fire or explosion, always use water to dilute the solution, and because the powders may accelerate the decomposition of hydrogen peroxide and the creation of oxygen. Keep the liquid away from all flammable materials and heat sources. The handling of hydrogen peroxide requires always absolute cleanness. So remember not to eat, drink or smoke when you are handling the hydrogen peroxide solution. And if the hydrogen peroxide solution gets spilled on the ground, you shouldn't collect that. You should dilute that with plenty of cold water and flush it into a drain. For safety, nearby the handling area of this H2O2 solution, there should be always a shower or a place to rinse eyes in case of an emergency. If your clothing gets wet by hydrogen peroxide, especially cotton or leather shoes, you should dilute the or rinse the clothes carefully with cold water and plenty of the water, because it may get on fire spontaneously. And when we look around the occupational safety, because the hydrogen peroxide is hazardous when inhaled, the most important things that you should remember is the safety limits. First things first. In 1 ppm, you can be around decontaminated area for 8 hours. In 3 ppm concentration, you can be around for 50 minutes. But in 75 ppm, it is immediately dangerous to life and health. So you shouldn't enter to space without proper safety equipments then. So it is always necessary to wear the respiratory masks when you are entering a space under the decontamination process, and always when the hydrogen peroxide concentrations are above those safety limits that I told you. The preferred filter type for the mask is P3. And in those high concentrations, the hydrogen peroxide vapor will cause strong irritation in nose and throat. The development of pulmonary edema is possible. But in real life, I would say around 10 ppm concentration, you will notice the concentration in the decontamination area, so that you don't want to be around there that long time. So that is.
One thing about this occupational safety, if you have to enter the area which is being treated, as Emma mentioned, this vapor is very irritating for eyes and skin. So paper coveralls and full mask. The respiratory protection has to be a full mask with a chemical filter. So it's not enough to have a half mask or painter's mask. So definitely a filter meant for chemicals. And there are regional differences on how they are named. So in most cases, the filters which military is using against chemical warfare agents are okay. But in some legislations, they may lack the marking for being suitable for industrial chemicals. So this should be checked as per each legislation.
Yes. And always the handheld detectors should be used for the detection of possible hydrogen peroxide vapor leaks.
Yes, here we have an example of a personal monitor. This is a Draeger XAM 5100, one of the most accurate devices in the market. We try to deliver these together with our devices, but we cannot have it as a standard equipment because due to the coronavirus, the demand for these devices have overwhelmed the Draeger's capability of delivering them. So there's currently quite long wait times, but nevertheless, a very important safety measure that should be always available.
Yes, true. The under the area under decontamination should be always kept clear from visitors, and a good practice for this is to use proper warning signs that says that do not enter to this area. So remember these things: protective clothes, eye or face shield, a cover, or actually respiratory mask, or actually a gas mask that has the chemical type of filter type that Panu mentioned. Non-flammable and gas-proof clothing, the handheld detector, and the warning signs.
Now this naturally applies if you, for some reason, have to go inside the area which is being treated. Normally, when you prepare the equipment and when you run the decontamination cycle, you are naturally outside of the area. So in a normal use case, you don't need anything else but the gloves for handling of the hydrogen peroxide and the eye protection if you need to handle with open bottles. But then you should have all those other gear available, even you have a slight chance that you may need to enter the area. But generally, if you never need to enter the area unless there is some issue that you need to attend to, or if you have to remove the machinery for a next target and let the other room to just naturally decay with the concentration.
Okay, so next we will dive deep into the decontamination process. We will talk about hydrogen peroxide vapor as a decontamination agent. We will go through the VHP process steps. We will talk about the variables that impact the decontamination process, how we can plan the decontamination process properly, and then we will talk about the critical process variables also. About hydrogen peroxide vapor as a decontamination agent, the good things in hydrogen peroxide vapor is, first, it has a very good material compatibility. It doesn't harm even the electric components. You can decontaminate areas which includes lots of different electric components, laptops or anything, because it has very good material compatibility. It decomposes into water and oxygen. It doesn't leave any traces or toxin residues. So it's an ecological method to decontaminate effectively. It is suitable for the decontamination of multiple different spaces and surfaces. I would say actually it doesn't have any limits.
Well, not really. Because you can leave all the electrical equipment switched on even during the decontamination process. And we haven't so far seen any visible impact on any materials within the treated areas. And as we have the unique ability to prevent condensation from forming, there is no real risk of any kind. And as said, while it's very friendly to any surfaces being in the area, it kills all the organic growth, bacteria, viruses, mold, everything. And if we think its benefits as a vapor, it really goes everywhere. So if we compare it to aerosols, they are at the mercy of gravity. But when we have gas, it really penetrates everywhere. So it goes inside things. It goes inside devices in the room. It goes under the furniture. It really finds every corner. Well, of course, during the treatment, as we will explain later, we will accelerate this mixing of hydrogen peroxide gas and air by using oscillating fans in the area that we are being treated.
Yes, and as told, it has very, very good penetration into all those hard-to-reach locations. And hydrogen peroxide is actually very, very efficient method to use also when decontaminating textile materials or those different types of porous materials.
There is actually one question from the audience that we can answer at this point. Simon is asking, what about if we do frequent treatment of very large complexes or buildings? Well, are there any side effects for regular treatments? Well, first of all, it doesn't really matter what's the size of the area. The size or volume of the area is simply dictating how many units or how much time is needed. And as we can avoid condensation from forming, it doesn't really matter how often the treatment is done. And the benefit of doing the treatment frequently is that you don't really accumulate that much contamination, so you actually can do the treatment with the lower concentrations that you compared to the situation that you actually have a problem that has emerged. So for example, in hospitals, frequent treatment helps keeping the MRSA and the other nasty bacteria at bay. However, if you only do the decontamination as reactive move, then you may need higher concentrations, and it's more complex matter in overall.
Okay, can I have a next slide? Okay, and when we look about these possible uses for hydrogen peroxide vapor as a decontamination agent, there are, as we talk about, there isn't actually limitations. For example, taxis, buses, rail cars, ambulances can be decontaminated effectively and easily and fast with hydrogen peroxide vapor. Also, hydrogen peroxide vapor is an effective way of killing mold from surfaces and items. For example, in Finland, mold and indoor air problems are huge problem in here in northern countries. So this is very, very important thing. It has no material damage. It has a long-lasting effect, and actually even paper, books and art can be treated without any material damage. So all of those can be saved from the mold contaminant with hydrogen peroxide vapor. Safe transport and storage of equipment and clothing, killing bacteria, fungi and mold before storing items reduces risks of those. Safer handling of equipment at logistic centers and longer lifespan for all of those equipments or all kinds of equipments. There are, when we think about, there are the possibilities to use this decontamination method in different industries and different places. There are hundreds of possible uses for this.
Actually, we can take a question from the audience at this point. Kauko is asking, what about use in meatpacking plants? So hydrogen peroxide decontamination can be used in any food industry, in any packing process. Now, naturally, when you do the decontamination, you don't have any consumable food where you do the treatment. This is for cleaning the process and cleaning the machines. So it's like a regular cleaning of any packing line First you do the physical cleaning, and after you have done the physical cleaning, you can do the hydrogen peroxide vapor treatment to remove any residual bacteria. And this is actually pretty much same process regardless of what kind of packing process you have. And the procedures are not that much different whether you are in a hospital operation room or whether you are in a meat packing plant. I mean, actually the execution of the decontamination cycle is surprisingly same.
Yes. So, as we already talked about with the food safety and leisure industry, the periodic decontamination of kitchen and other food preparation areas and food manufacturing, that would be very efficient. I often get a lot of questions about hydrogen peroxide vapor. Vapors are efficient in different types of microbes, bacteria, viruses, and fungi. Here we have a quite efficient, visually efficient table of the resistance of different kind of microbes to hydrogen peroxide vapor.
And we can see actually many surprising layers, because one of the most frequent questions that we get these days is that does this work on corona?
Yes.
And enveloped viruses like corona are among the easiest targets. And all our performance data, when we talk about 6-log kill performance, we are talking about bacterial spores, something like anthrax. So enveloped viruses such as corona, Ebola, and most of the mold spores, they are the easiest target. Most of the bacteria are somewhere in between, but to answer this question, what about effect on corona? Well, it has been investigated by many international scientific teams, and there are a lot of published results on that, so we are not going to dig to any deeper on that. We just go behind our statement that this kills bacterial spores, and there is nothing worse than that. So when you can kill anthrax, you can be sure that you are killing the corona as well.
True.
And unlike, for example, UV light, this is destroying also viruses from surfaces that are hidden. Now, with this said, we also often get questions that what about blue light and UV light? Well, they are excellent for air filtering. So as an ongoing process, deployment of blue light and UV light within air filters and AC units, it's a good idea. It keeps the air fresher, so there's no doubt about that. But it doesn't remove the viruses from surfaces. There was another question which we can take at this point. There is Mr. Doe is asking whether this can apply to food processing, and can this be used for eliminating bacteria in food? No, it can't. So this is not something that you can use for consumable food. This is a method that you can use for decontaminating the equipment and machinery which is used to prepare or pack or transport the food. So this is really not something that that can be used as a like a hygiene method of food which is already of something which is supposed to be eaten. And there was also a question from Ossi about the isolation level of buildings that are being treated. So the most important matter, which we will address later on as well, is that the treated space needs to be isolated well enough that there is no gas leaks to inside. So if there are some leaks to outside air, that doesn't matter. But as long as you don't expose any neighboring areas, or you have to vacate the entire building in that case. But typically normal office room when the air ventilation system is taped and the door frames are sealed with duct tape, it's tight enough, and there are no leaks that can be detected. But let's go forward so that we can keep the time schedule.
Yes. Next slide, please. Actually, I think Panu can talk about this subject.
Yes, this hydrogen peroxide vapor, it has been known for a long time that it can be used for neutralizing chemical warfare agents. And mustard gas, for example, is effectively neutralized with just hydrogen peroxide vapor without any additives. When it comes to nerve gases like VX, then a little bit of ammonia needs to be present in the area being treated. Now, some of you may know that nerve gases in room temperature, they are liquids and they are spread as aerosols. They are not really gas in its actual sense. So ammonia acts as a catalyst in the decay process of a nerve gas. So either it's injected to the process or it's fed into the area being treated separately. So for those purposes, we have special models that can handle both of the liquids. It's generally a bad idea to mix ammonia, even mild ammonia, and 50% hydrogen peroxide. It will result a very how would I say, unpleasant exothermic reaction. So in other words, it starts foaming. The hydrogen peroxide starts decomposing at very high rate. So there is I would say, occupational risk involved. But anyway, if your use case is about this particular topic, we have special models and methods for that purpose. Well, there is a question from Thomas regarding this. So what about material compatibility with VHP ammonia? We haven't seen any compatibility issues. So this has been tested by NATO, this has been tested by our military. And the amount of ammonia that needs to be present is so minimal that it doesn't have any notable joint effect. And there are also a lot of international research papers available on this topic. So Emma, please.
Yes. Can I have the next slide? Okay. Then when we look around the VHP process steps, in 3 steps. First, we have the generation of the hydrogen peroxide vapor from this 50% hydrogen peroxide liquid solution. When we have generated the hydrogen peroxide vapor enough to the target ppm concentration level, then we have the decontamination process. The hydrogen peroxide vapor levels are maintained at the target concentrations, and of course the device does that by itself automatically, and it keeps the even concentration all the decontamination period. After that, we will move to the aeration part, and we will aerate the area below 1 ppm concentration. And the device does it also by itself. It starts to run the process down and aerate the area.
Yeah, the time in minutes on this graph is actually quite pessimistic, because normally the actual treatment time required varies from like 30 minutes with an ambulance to hour plus with the hospital room, depending on the actual biological target that we have in mind. But there is one important thing to note from this graph, and that is the missing of the air drying part. So I think most, if not all, of our competition, they require that the air needs to be dried before the treatment. Now we don't have to worry about that because our sensor suite and our system software makes sure that we don't have a condensation risk even if the starting humidity is extremely high. So we have done hospital room decontaminations in tropical climate where the starting RH has been more than 70 and they have been successfully concluded.
Can I have the next slide? So, and when we look the variables that impacts the decontamination process, things we need to be aware of is the temperature of the treatment area, humidity, the total volume of the enclosure, and the shape of the enclosure. Because when we are planning the optimal distribution of the vapor, we need to be aware of the shape of the enclosure, the leaking properties, or the quality of sealing, the surface materials and their areas, the temperature differences or deviations within the enclosure, the aeration options. Can we do the aeration through windows, or do we need to use the catalytic converter or converters for the aeration part? The optimal distribution and delivery of the hydrogen peroxide vapor on all surfaces needs to be provided, because that is the only thing we can do for to ensure the efficient enough decontamination process. And for that we use the air circulation fans and blowers. And always you should note the air pockets.
Yeah, typical air pocket, for example, can be a closet or drawer in the room. So if you have like a desk with drawers, you open the drawers and you place a fan so that it's pointing to such enclosures. If you have a closet, you keep the doors open and so forth. Now the fans don't need to be anything special. They can be just standard fans that you can find from any hardware store for 10 to 20 euros. We do also have a special fan with a HEPA filter. So if we are in a location where dust or contaminated dust may possess an issue, then it's a good idea to have a special fan with a HEPA filter to prevent unwanted particles spreading around. Now the fan that we provide, it looks pretty much like the catalytic converter we have here, but the filter is just HEPA without the catalytic part.
Yes. We have a question there from Pepe. What type of surfaces are the most difficult to deal with?
I would say that if you have porous surfaces, so like plastered wall or like a brick wall like this one, because they have a lot of porous surface. The plastered wall is maybe the worst. So we had some testing in Spain where the rooms were not particularly large in volume. However, the plastered surface made it really hard to get high concentrations, and the residual tail concentration was quite high. Now the other materials, maybe just soft fabrics, so like a sofa, for example. The gas doesn't really penetrate deep into soft fabric without special methods which can be of course applied. But fundamentally the more like a hard or solid like a metal or glass, that's easy. But if you have like a rug like we have here, this is causing issues because it's absorbing a lot of the vapor, and it affects how fast and how high we can get the concentration. There's another question related to this. Simon is asking, are the standard fans controlled by the clean mix units in the aeration phase? So the fans don't need to be controlled by our device. Our own fan, of course, can be switched on and off, but the fan is supposed to be on throughout the process. It doesn't matter whether we are doing the treatment part or the aeration part, because the fans also expedite the aeration. And the fan has also another purpose, not just mixing the air, but it's also bringing fresh vapor concentration towards the contaminated surfaces. So it's actually also acting as an accelerator for the process. And same applies when you want to get rid of the concentration. The more you have air circulated in the area, the faster is the aeration process in general. So the answer is that the fans don't need to be controlled by our device. But if you, for some reason, want them to be controlled, you can use, for example, remote controlled plugs and switches, which are readily available as well.
Yes. And adding to that, I would say that the hydrogen peroxide vapor is a very lazy decontamination agent. So it's important to get the vapor to properly spread into the decontaminated area properly. Okay, and then we will look for all the critical process parameters and to understand their effects so that we can plan and make efficient decontamination processes. The higher the attained hydrogen peroxide ppm level in the shorter the time is needed for the decontamination. So the time and the ppm levels are going hand by hand together.
Yeah, we are talking about exposure. So high concentration requires shorter time for the same exposure. And this term ppm, I think it may be familiar to most of the audience, but if not, it means parts per million. So 100 ppm is 100 of the million in a volume. So that practically means how much you have in a cubic meter.
Yes. The high humidity levels enhance the microcondensation on surfaces, but at the same time the limits the building up of the hydrogen peroxide vapor concentration in the air. So the humidity is one of the most important things to consider in the or look in the process.
Yeah, we have a control on the humidity, as we can, Emma will soon explain more about this RS value that we are referring here, which is the combined humidity of hydrogen peroxide and water. Now, some microcondensation always happens, and as I mentioned earlier, high starting humidity is not really a problem for us because our machine can keep its output at the level that we never hit the actual condensation point. But at the same time as high humidity and high temperature increases the effectiveness, then low humidity and low temperature, they do the reverse.
Yes.
So you need more time for the treatment in dry winter season than you need in the humid summer season, at least here in Finland.
Yes. So 3 main things you need to be aware of and understand their effects are the ppm levels, the H2O2 concentration, the time, and the RS. About the RS, the relative saturation, I will tell you a bit more on the later slides. When we are optimizing the decontamination process, the continuous measurement of the decontamination process is very important. The maximum achievable vapor concentration is depending on the existent environmental conditions. For example, the temperature, the relative humidity, or the relative saturation. It needs to be taken into account when we are planning the decontamination process. It is not possible to get concentration past the condensation point, and the condensation point is 100% in the RS parameter.
Yes, in our documentation we have this chart, complements from Vaisala Corporation, which is showing for each given temperature and each given relative humidity at the start, it's showing what is the maximum attainable concentration of hydrogen peroxide under those conditions. So you can see that if the air is dry, it's easier to get high concentration, and same applies if the ambient temperature is higher. But generally, most decontamination processes take place in normal room temperature around 20 to 24 degrees, which means that the attainable concentrations are anything between 200 and 500 ppm typically. Of course, in very dry air, higher concentrations are possible.
Here we have the picture that this is a good picture to look to how to understand the relative saturation and the relative humidity. So our Vaisala sensor is measuring both of these parameters, the relative saturation and relative humidity. On the first picture, you can see there is only this water is appearing on that space. And as we can see, the RS percent and RH percent, those are quite same. It doesn't have any changes on the parameters. But when we add the hydrogen peroxide vapor into the hydrogen peroxide into that space, actually the RS percent is increasing and the RH percent is lower than the RS. And so by this we can say that the RS percent is the only parameter, the relative saturation is the only parameter that tells us the condensation point and how near or how far we are from the condensation point. Of course, we have very smart device which takes care of the that we don't hit the condensation point. But these are things that you should understand when you are doing the decontamination process and when you are, for example, setting up for the parameters. What will you set up for the RS limit for the device? Here on this picture, it's pictured the changes of the temperatures inside the area or the enclosure. As we can see, we have there this Vaisala sensor, which is measuring the temperature and also the RS percent, the saturation. Then we have the window over there, and the temperature there is a bit lower than what the Vaisala sensor is measuring from the air. The air is warmer than the window. And as we can see, the RS is completely different with this. So, what we can learn from this, the temperature changes inside the enclosure are affecting to the decontamination process by that the condensation can be appearing on these surfaces which has lower temperature than the air inside the enclosure.
Yeah, so if you have steep temperature gradients in the room, it may result condensation, and as you said, especially on the windows. And this is very important to take to attention if you are decontaminating something like ambulance or bus or train car or aircraft. Because if the target has been in cold air, or if the ambient air outside is very cold, you may have cold surfaces which may attract condensation, and without the sensor understanding what's going on. So, for example, if you do an ambulance, like here in Finland, where we mostly have cold weather, it's a good idea to take it indoors few hours before the treatment. And especially if you do decontamination of something more sensitive like aircraft, if the aircraft is in cold outside air, you may get condensation in windows, and that can damage the rubber ceilings of the windows. But it can all be avoided with proper planning and having a proper procedures and checklist in place.
And when we are looking the different types of our methods used with hydrogen peroxide vapor, and of course affecting this saturation with our device, for example, because when we're talking about the hydrogen peroxide vapor method, we talk about this dry method, then also mostly the aerosol methods or the wet AHP methods. With our device, it's possible to actually do all of those different types of methods.
Yeah, that's correct, because there may be some extreme situations. So, for example, if you have like a sea auris or something really nasty that has been absorbed to porous surfaces, those are the rare situations that you may actually want condensation to occur. And it's technically possible, but we don't include it in our standard procedures. But when we'll go through how the program parameters are set up, we will also show this. But this is sort of things that don't try it if you are not absolutely sure that that's something what you want to do. We may, Emma, be required to speed up a little. We are going short on time because we have only 40 minutes left or something like that.
Yes, of course. Next slide, please. Okay, just let's go through quickly about the testing and validation, because of course it's a very important thing to how we can prove and how we can know that the decontamination process has been done successfully. The decontamination verification, what we need to verify from the decontamination process is the vapor distribution and the effectiveness of the process. And these two things can be made with the vapor distribution can be verified by chemical indicators, and the effectiveness of the process can be verified by using biological methods and indicators. And thing to remember always at the decontamination process is to always have the mechanical careful cleaning of all surfaces before decontamination process, because it is very unlikely that all the microbes are being eliminated from the surfaces that are covered with visible dirt or mold. But of course, if we have badly contaminated area, of course we want to first make the decontamination there, and after that make the mechanical cleaning, and then again the decontamination process to have a safer working area. What can be used for the verification is contact tests. This is a very easy and quite fast method to see what has been eliminated from surfaces. There can be used these hydrogel contact tests, or for example petrofilm contact tests. Usually the incubation takes something from 1 to 5 days after the sampling. Chemical indicators are, I think, the most important thing for us with the verification of the decontamination process, because with chemical indicator we can verify that the vapor has been in contact all of the contaminated surfaces.
Yeah, chemical indicator is a real-time method, so it's very very useful for observing how the process is going, and therefore it's always a good idea that if you have any means of having a visual line of sight inside to the area. So if there's a window, you can always put a chemical indicator tape facing the window, and you can see, for example, if the process has been faster than you expected or slower than you expected, because that really shows you the effect. It's pretty accurate. It's not official, but actually here we have a reel of tape. So what we have seen in our practical use cases and testing, this tape has been following very closely the confirmed results of the biological indicators, which are the official ones. So this is very easy to stick somewhere around. As Emma mentioned, you put it in multiple locations so that you can see that the hydrogen peroxide has done its work. And for putting it in a window, you fold it like this, and you put it against the window, and that allows you to see the results from outside.
Then we can also use these biological indicators. And for example, all the tests, effectiveness tests made with our devices are always made with these biological indicators. We use these Apex indicators, which are made inside of a TÜVEC pouch, which includes inside the carrier where the microorganisms are put into. The incubation of biological indicators takes 7 days. So it takes a bit longer time, but I think this is the most efficient and most, ensuring way to verify that we have, for example, if we are looking for this 6-log kill, we can verify the result with these.
Yeah, this is a especially practical way of ensuring that certain established procedure has sufficient treatment times, and that's really the official proof. Now, most of the biological indicators are on metal plates, and more realistic results can be achieved if they are put on soft pads, like a liquid biological indicator on a soft pad, and that is, I would say, extremely realistic if we think about like bacterial spores, decontamination, and not too many of our competition ever does that, but we will show you some examples coming. Let's go forward.
A bit about the validation that has been made with the devices. Always qualification report includes 3 parts: the installation qualification, the operational qualification, and the performance qualification. We can go forward. And actually, I think we can.
Maybe we can go to the setup of the devices at this point.
Few use cases. I think Panu can.
Yeah, we can at this point, before we go to setup, we have been asking a lot about ambulance decontamination. We have done a few of those. One of the earlier cases we discussed in our previous webinars, we had a new one 2 weeks ago here in Helsinki. So ambulance is pretty straightforward target. You simply take out unnecessary items, for example, blankets, pillows, things like that. There is enough room to put in both catalytic converter and the device. And it's relatively simple to take biological samples, like Petri film samples. And the treatment time is relatively short. So we simply put the device in, we set the ppm target to 250 to 300, depending on the conditions and size of the ambulance. With normal ambulance, you need 2 oscillating fans, one for this patient passenger compartment, and the other one pointing to the driver's section or the driver's cabin. And in some countries, ambulances don't have any access between the driver's side and the passenger compartment. In Finland, most ambulances have just an opening there. So it's a good idea to have one fan making sure that the air distributes inside the driver's section and the other one mixing air in the cabin. Now, ambulance case, you can also use the internal air circulation. So all AC systems have this closed loop option. There is just one word of precaution. Make sure that there is no active carbon filter within the inside air distribution, because active carbon would act like a catalytic converter. It would just simply destroy the vapor concentration, and it would also shorten the lifespan of the carbon filter. So in our examples, we didn't use the internal circulation because the ambulance owners were not sure whether there's a carbon filter in place or not. So as at treatment time, typically it's been 20 to 30 minutes. We had one case where we had extremely cold ambulance, surfaces were cold, and that took 45 or 50 minutes to complete. But in all of those cases, we got total process time in less than an hour or slightly more than an hour in this one example. Because ambulance is easy to aerate, you simply open the doors. And even if you are in a garage, the garages typically have very good ventilation. So just keeping a slight distance while the tail part is being evaporated, and that will take care of it. Do we have these sample examples on these slides? Yes, please,
Yes.
Let's go forward.
Next slide, please.
Yes. So 2 weeks ago, we did a comparison testing. We had a Clemix device and we had a Nocospray aerosol device. 2 identical ambulances were treated, and these biological indicators were actually soft pads. So we had there was absorbed samples in a soft pad, which is very difficult case. And the results were analyzed by National Research Center VTT, and it showed that the standard Nocospray process had 0 effect on any of the biological samples, while we had a 3-log kill on these particular, very hard to kill samples. And on the left side, the 3 bars are comparison samples. Then the 3 following ones are ours, and the 3 after that are the Nocospray affected samples. One of the samples was actually just next to the nozzle of the Nocospray aerosol device, and we can see that hardly any effect. That's the middle one, by the way. Let's go forward. And here we also have the Petri films. And we had 3 samples taken before the treatment and 3 samples taken after the treatment. If we go from left to right, the first one is from the steering wheel. The next one is from the passenger side floor, about where the devices were placed. And the third one is by the rear doors of the ambulance. And what we can see is that all the aerobic bacteria was killed after the Clemix treatment, and none of the aerobic bacteria were killed after Nocolus treatment. So I guess you can all make your own conclusions what this means in reality, and what works and what doesn't work. So let's go forward. And here are the chemical indicator tapes. And as we can see, the aerosol had 0 effect on the chemical indicators. And if we take one step forward, and we can see color change on all chemical indicators that were affected to the Clemix treatment. And this treatment, if I remember correct, it was about 40 minutes or something on those lines. And then we had about 20 minutes aeration after that. We only had one fan available, so we put that in the passenger cabin part. But nevertheless, it worked nicely on the driver's side as well. So let's go forward.
Let's take. There is few questions about the ambulance decontamination. Pepe has been asking, do we need to cover the heating or the AC blower nozzles?
No, it's not necessary. We have analyzed if there are any leaks outside, and only if the internal air circulation was on, which we tried a few times, that caused some very minor leaks outside of the vehicle. And T1 is asking, what's the parameter to determine the time? So ambulances are of different shapes and sizes. The most common here, which is in Finland, which is made of a Mercedes Sprinter. We have used target levels of 250. And the time, how we determined it, we followed the change of color on the chemical indicators which we put on the driver's windows. The rear windows are dark, so you can't see through. And of course, the device is in the passenger side. So if there's a color change on the tapes on the driver's side, you can be pretty sure that the treatment has been enough on the passenger side. So we have tested in multiple occasions and came to conclusion that sufficient treatment time is about 30 minutes under normal ambient conditions. And Staves is asking the time indicated is related to concentration of, so he's asking that did we use 50% liquid for the process? Answer is yes. And if you use a weaker solution, you may need a longer time. However, the buildup of the concentration in a small enclosure like ambulance is very rapid. So it's only about 10 cubic meters, almost too small for our machine. So I would say that if we would use like 40% liquid, there would be no notable difference in such a small enclosure. There would be more humidity, of course. Okay, so I guess we need to go to the actual machine setup pretty quickly.
Yes, we can go forward. So let's get on to the hands-on learning part. We can quickly go through the last slide. So here on the slide you can see all of our devices that we have. We have this VCS20 made for the smallest enclosures. Then we have the VCS100M and then the VCS100CR and CR extension unit that we have also here today in our studio.
Yeah, we had earlier a webinar where we dealt with the older model, the M model, which is master only. And here we have a system which is the CR, the expandable system. So we have a master device, and one master device can have I think it's currently for practical reasons set to maximum of 50 extension units. Yes. So it allows treatment of pretty much unlimited volume. So we got a lot of questions lately about the setup and use of these devices. So we decided to have them as a topic on this webinar. Because of the COVID outbreak, we haven't been able to do any on-site hands-on trainings outside of Finland. So let's do one now and see how this is set up. So what we have here is we have the VCS100 master, we have the extension unit, we have the catalytic converter, we have all the accessories, sensors, bottle, the hose set, and this time we also have sensor for the extension unit. It's not really mandatory, but it gives you more information for the process control. So Emma, where would you start? We have just arrived on the scene and we have placed the machines. What happens next?
I would first start with the bottles. I would change the cap of the bottle to the suction hose set. And for the safety, you should always wear the gloves and something to wear protect your eyes and face.
Now when you attach the cap, you don't need to put it too tight, just that it's firmly in its place. And then you attach the hose connectors, and you can't really do them in wrong order. You put them firmly in place. This is the input. This is any excess liquid output. And of course, this time we are using water, so we don't really need to have all this equipment. But as said, just a reminder, when you handle the hydrogen peroxide, it's always a good idea to have the protective gear available.
Yes.
So it's next part can be attaching the power cord. It is attached same way in all of the devices. You put it a little bit sideways in, you press it down, and you turn a little bit clockwise, and it's firmly in its place. The sensor that goes here, and you have a little red marker pointing to the red marker on the plug here, and you just put it firmly in place. To remove, you lift the sleeve and it comes off. Okay. Now the placement of sensor, you want it away from the output. The fresh or the new vapor is coming out here, so it's a good idea to place the sensor as far as possible. Now we don't have here anything really to put it hanging loosely, so I put it here, and remember to remove the cap from the head of the sensor. Now this machine would be ready for powering up, and this time we have other accessories around us, so we are networking them together. So we are using an RJ45 cable. This is normal Ethernet cable. I have here multiple connectors. I can choose either Ethernet 1 or 2, and I just put it on the slot here. Now these machines can be networked in any order, so you really don't need to have them in any particular order. So you just make sure that you have a control cable going in to one machine, and they are forming an IP network. So Emma, you can take the other end here. Of course, these cables get tangled every time. So we have now a network where the master device, an extension unit, and catalytic converter, they are connected to each other, and they form an IP network when they are powered on. Okay. And we also have the power cable here on already. Now this one was a little bit tight, I guess.
Yes.
Like this. Yep. Okay, so now we are ready to power on these devices, and it's always recommended, like with any IP network, that you start from the master, because this is the DHCP server for all of these units. And after this one has booted up, it will give the IP addresses for the other ones. And catalytic converter, remember to power it up as well. Now, this is the older model. The newer model has here a switch which has positions 1 and 2. The position 1 means that it's controlled by the master unit. And if we switch to position 2, it will be a black switch right here, then it means that it's power controlled, and it can be also be used with the older M series device, which is having a power on, power off way to control a single catalytic converter. Now this is also a good time to switch on our personal safety monitor. We press it for 3 seconds and it will boot up. Okay. Here we have our control tablet. We can use any Android. Do we have an iOS support for CR series yet? I don't think we have. I think it's still coming. But you can use any Windows machine or any Android machine. And each one of our devices, they come ready with a pre-configured Android tablet. So this unit forms a Wi-Fi network, and the control tablet connects to this network. So when you unlock it, you can see I have here 2 applications. This application is for the older M series, and this one is for the CR series. And when we boot it up, it will have the same display as we have here. So this is mirroring what we see here. And the Wi-Fi connection, we have the SSID here. So if you use some other device or you install the control software on another device, here is the specific SSID for this unit and the specific password. And in the instructions manual, you can see the rest of the settings. It's also a good idea to remove this padding before we start the actual work or the cycle, and we would take this away from the room. Now, Emma, I will hand this now over to you so you can guide us through the next steps on the configuration.
Okay.
Do we have camera view to the screens here? Good. Okay.
So here we have the login page. Your using organizations, you can have these personal IDs for your use, or you can enter inside through the default user login, which we will use now. From here, we can have 2 options that you can see on the right side or the right corner. There is this self-check option or supply page. First, we will go to the self-check phase. On this phase, the device will test all the critical functions of the device. For example, the fans and the pumps and the heat units.
And note that when we have a master and slave connected, the slave unit, I don't know if you can hear it, but the slave unit was also running its fan for a period of time.
Yes. And on the screen you can see there is the percentage going, and when the all of the functions have this 100% achieved, we will be ready to continue. And from the right corner on the up, we can go to the settings. From here, first we will go to the supply page, which we saw earlier on the first phases. So here we will set up the amount of hydrogen peroxide liquid. And now we have around 500 milliliters on our bottles.
Yeah, this bottle is 1 liter, which is 1,000 milliliters. And the amount is entered in milliliters. And 1 bottle is sufficient for 5.5 hours running time at full output power.
Yes. Here we can also add the target size of the decontamination area. Here we don't have now a real decontamination situation, but you can
let's put their typical hospital room like 50 cubic meters.
Yeah, okay. And then we will add the set point, which means the target ppm concentration we want to have.
Yeah, we can do it here, or we can do it in the program parameters later. But why we have it here as an initial menu is that these are some of the critical things that you should not forget.
Yes.
So that's why we have them here as well.
Yes. We can now look around for 250 ppm, for example. And there you will see the theoretical ppm level. But as I say, usually when I'm training, this actually doesn't have anything in common with the real life. There is so much affecting things in the decontamination process, so you shouldn't look around too tightly to this value here. Then we will go forward, and here we can see the settings page. Here we will set the parameters for the decontamination process. What do you think? What is the good time for this regular hospital room decontamination? What if we have a coronavirus contaminated area? What would you do with that case?
Well, first of all, I would normally have a background data on earlier treatments in that room. So how much do we need time on in that particular area for a 6-log kill? But if we have a typical single bed hospital room, that's 40 to 50 cubic meters, hardly any larger than that. With single device, we can expect that we get 6-log kill in any time from 1 hour to 1.5 hours. So, so if we set the target ppm to say 300 ppm, and we initially put the time to 1 hour and 30 minutes, if we have a way to observe the chemical indicators inside, it may result shorter or longer. Now, one thing to understand, good to remember, is that we can change the parameters while the process is on. So parameters can be changed live at any given time. So to answer your question, I would initially put there 1 hour 30 minutes, put target to 300, and observe it. Now, it might be possible that we have done it earlier and we have already some prior data, because we have had situation where we had a 70 cubic meter hospital room and we got 6-log kill in less than 40 minutes, but that was very humid and very hot climate, so that also accelerated the process.
Yes.
We have a question there, which is from Simon about RJ cables. Well, these are Ethernet cables. So, what's the maximum distance that the units can be apart? So it's actually determined by the length of the Ethernet cables. So it can be up to 50 meters, I guess. I haven't really seen longer Ethernet cables than 50 meters. Yes, it's a good idea to have enough of cable, and our standard cables, I think, are 10 meters at least. Now, we didn't have it yet ready for this training, but we are coming up with the wireless option as well. It's being tested as we speak, actually. So we can have a wireless plug that goes to the Ethernet jack, and that also allows mixing of wired and wireless connections between the devices. Now, generally, it's considered safer to have a wired connection, but of course, it's more hassle with the cables. But as said, the maximum distance is only determined by the length of the cable itself.
Yes.
And there was an earlier question before it goes to the out of the screen there. What's the expiry time of biological indicators? Well, that's vendor specific. So you need to check the vendor's instructions or packing, and there is typically clearly indicated what is the maximum shelf life.
Yes. So here, as you can see on the screen, we have set up the treatment time on the first row. Then we will set up the target ppm level. What is the target concentration for the process? Then we will set the RS limit. I think the 80% is quite good to use almost in any situations.
Yeah,
What do you think?
it's been sufficient everywhere except in tropic. So in tropical climate, I've used the setting of 88, and the highest RS in a hospital room treatment I have seen was 87. So I never needed any higher than 88.
Yes.
I wouldn't put it much over 90 because it's always possible that the residual output, even if the machine has stopped pumping liquid into the process, it may still raise few percentage after it slows down. So I would consider that putting 99 there would be like a little bit too risky.
Yes. Okay. Then we will set here the ppm level where the treatment time will start to run. Here you can add anything from 5, for example, from 5 ppm to 250 ppm if we have a target ppm level of 300 ppm. I would set up here maybe 200 ppm or something.
There was another comment from the audience that the Cat6 cable has a maximum length of 100 meters, but in real life decontamination cases, you never need those kind of distances. So we can say that the cable length has no influence. I think we have audio questions from audience. So Tuomas, please.
Yes, so we had a question from Crinsanto Santosa. He asked for such follows: waiting for its application to decontaminate protecting masks N95. Will you have the demo? Question mark.
Okay, there was some echo on the line, but was the question that if we decontaminate N95 masks, what kind of treatment times are needed? Was that the question?
Right.
Okay, so there's actually right now a very interesting test series going on, supported by Finnish military, and they are using our Climix devices there for generating the vapor. And depending on the concentration, it seems that the treatment times from 1 hour to 2 hours have been used, and they will publish official reports, hopefully, if not this week, next week, and they will there define exactly what kind of concentration levels and what were the corresponding times that they were using. But I've seen some of the preliminary data, and it seems that they have used 1.5 to 2 hour treatment times, and they have been also experimenting what is the shortest safe time that this can be done without taking any risks. But based on the information we got and what has been publicly discussed, this pilot line that they have there for recycling masks, it has theoretical capacity of something like 75,000 masks per day. And in practice, I think they have been running at the rate of 40 to 60,000 masks per day.
Yes. Okay, and going forward with the setup. So on the last rows, we have the report file name and the target info and notes. To the info and notes section, you can add some notes about the decontamination process. What do you think it's the information that you might need on the report that will be written on the report after the treatment. The report file name can be add, for example, like this. You can update the time and the date to the report file name, so that will be done. On the right corner, the first button over there, you can see the circulation button. When we press that, the device will make this circulation effect or function with the hydrogen peroxide bottle, where the liquid will be circulated, as you can see on the picture. The liquid will be circulated through the hoses and through the device, and all the these air bubbles will be.
Yeah, seeing air bubbles is completely natural, and that's because there is in these pipes there is quite rapid natural decay of the hydrogen peroxide, and when the system is circulating, we call it filling the system or bleeding the system. It will make a full replacement of the old liquid in and replace it with a new one. Now this same process is used for flushing the device after the use. So now we are supposed to have hydrogen peroxide here, so we just removed the distilled water that we had used for flushing after previous treatment. And now once we are finished with the decontamination cycle here, what we will do, we will replace the hydrogen peroxide bottle with the water bottle, and we will rinse the system so that we remove the hydrogen peroxide, and that will extend the lifespan of the pump, the hoses inside, and the valves, and so forth. So technically, it's not mandatory to do so, but it's a good idea because, as said, it's like changing oil to your car or something comparable.
Yes. Okay.
And why we do it now, the other reason, of course, is that the pumping rate is only 3 milliliters per minute. So if we had an empty system, it would take several minutes to fill up, and it would unnecessarily slow down the decontamination cycle.
Yeah. Okay. And then when we have set up on this settings page the parameters, we can go forward to this button on the right side. Here is the catalytic converter button, and here we can make the setup for the catalytic converter. It can be run automatically with automatic control or the manual control. With the automatic control, if we want to use that, we just press from the button so that it says on, and then we will set up the automatic ppm range, and that is the range where the catalytic converter will be on. For example, if we have this concentration target concentration of 300 ppms, we can set up the catalytic converter to start automatically on the 300 ppm. Sometimes I get questions that will the catalytic converter start during the decontamination treatment while the device is still making the process. No, the catalytic converter will start after the treatment time has been done.
We also get sometimes a question that why we have this range here. Why do we have the maximum and minimum? And there are one reason, a good reason for having the maximum is that, let's say that we have the target of 300 ppm, and we want the concentration to decay naturally to start with. So we want to have the concentration to do its decontamination work for a while, even after the actual vapor production has stopped. So let's say we had target of 300. If we set the catalytic converter to start at 200, we will have the benefit of all the residual concentration before we start the aeration. Of course, that depends on how much time we have. And then the stopping point, if you have it as a 0, it will run forever. But if you, for example, leave the aeration on for a weekend or overnight, you may want that it stops somewhere. So it may be a good idea to have it stop at 3 ppm, for example, because that is a limit for safe temporary exposure. So then you don't unnecessarily consume the catalytic filter. I mean, that has normally lifespan of about a year or so. But if you just run it for several days in a row, I don't think it's a good idea anyway.
Yes.
So that's why we have this range that we can choose.
Yes.
There is a question from the audience. Would the hydrogen peroxide vapor reduce or eliminate biofilm? I'm not sure if I translate this correctly in my mind, but let's say hydrogen peroxide is killing all the microbial growth, but it may not remove the physical residues. So for example, if you have visible mold on a structural surface, the hydrogen peroxide vapor will kill it, but it doesn't remove the mold stain. I don't know if that answers the question or not, but as said, it kills the organism, but it doesn't remove the residual physical material.
Okay. And now when we have set up the parameters for the process and the parameters for the catalytic converter, we have the possibility, if we have, for example, this hospital room, which we will decontaminate, for example, every day or every week, we will do this regularly. We can save these process parameters for the further use by pressing from here on the right side. We have this save button. By pressing this, we can save this receipt or these process parameters for the further use. Just adding the name you want to have for the receipt, and then it's saved. And if you have already saved some of those receipts or process parameters, you can have them for the use by pressing load, and from there we can take the receipts to use.
So we can create pretty much unlimited number of preset cycles for various purposes. Right now we don't ship with preset cycles, but user can program them freely. We are actually appreciating your feedback on what type of preset programs might be most wanted, because many of those can actually be shrunk into list of maybe 3 to 5 basic categories. There's also a question from audience. Ossi is asking about what about cellulose-based materials like paper and colored mask? Now the answer is that hydrogen peroxide vapor doesn't have any effect on paper or today's normal paper. What we have seen is paper that was from mid 1800 that had a tendency to have yellowish tint after treatment, but when I spoke to experts from VTT, they said that it's some of the chemical that was used on that time for the paper process, and it's no longer used anymore. It wasn't chlorine, it was something else. But then on very old paper, we haven't seen this effect. So it seems to be subject to certain era about mid 1800 or something like that. Then we had a old document having yellowish tint. Now it wasn't destroyed, it just had a little bit color change. But then I know that in some countries they have treated really old parchments and really old paper documents, and no difference before and after.
Yes. Okay. Then when we have the process parameters already set and done, we can go to the dashboard, which you can find from the left corner. Here we can monitor the decontamination process through the complete process, and also we can here start the process and pause it and stop it. Here on the right side we can go to the extensions page. Here we can see all the extension units and the catalytic converters that have been connected to our master unit. As we can see, we have there one extension unit and one catalytic converter connected.
And you can also see here that we see telemetry data from the extension unit. Now, having sensor on the extension unit or extension units, it's not mandatory. It's an option, but if you have a very large volume, having the extra sensor gives you better understanding of the overall process. So we can see on the screen not just the ID and the status of the extension unit, but we can also see the sensor data. And if we had multiple catalytic converters, they would be by their IDs on this list below. And as said earlier, you can connect extension units and catalytic converters in whichever order you want. So only one master unit is required, and from the master unit, it doesn't matter how you connect the rest.
Yes. Only need to remember that master units cannot be connected together, and also you shouldn't make a loop formation of the devices. That cannot work.
Yeah, so don't connect the last extension unit back to the master.
Yes.
So this should be a line or a star, but not a circle.
Yes.
Like any TCP/IP network.
Yeah. Okay, from the extensions page, we can see on the right corner this Enviro button. We can go forward to there, and here we can see all the parameters that the Vaisala sensor is monitoring and measuring. Here you can see and look the parameters, for example, before starting the process, when you are planning the decontamination process, or during the decontamination process. When we go back to the dashboard, here, when we have set up the parameters for the process and the catalytic converter, we are ready to start the decontamination process.
Or almost ready. We might want to do some practical things before that, but let's first go through some of the... Can I borrow the stencil there? You can keep the tablet. So if you can focus on the screen here. So we have here all these indicators, as Emma explained. Now this little figure here, which now shows 0.0, that means change per minute. So when the process starts and we start getting concentration climbing up, this will show you what is the change rate per minute. And that gives you a good indication on how fast the concentration is building up and what to expect for the overall performance. And same applies for the RS and RH. So it will show you the change per minute. Right now, we have slight variations, but you also should note that now that we start, RH and RS are showing the same exact figure as they should, because we don't have any hydrogen peroxide in the air yet. So they are showing exactly the same. And once we start the process, the RS will start increasing much faster than the RH, because hydrogen peroxide has much, let's say, it has higher tendency to condensate. So the RS will be climbing faster, and this is the one that you need to pay attention to. And whether your RS limit is too high or too low, you can make conclusions based on the change rate. So if it changes very rapidly and you don't have much concentration, then you may have really challenging conditions. And the time here, that is the actual treatment time. So when we actually hit this point where we start the treatment. So here it has been set to 200, which is actually quite high because it may take a lot of time to raise to the 200. But that is the time counter that shows how much time we have left since we crossed the barrier of the treatment time. Now the other thing you may want to do at this page or this time before you start is to set the graphical display. We have two different graphs, and you can choose what you are showing there. So normally, I mean, this is highly of personal opinion, but I tend to have only the concentration, the ppm on the upper part, and that scales automatically. And on the lower part, I normally just keep the RH and RH. Now on our latest software edition, the scale here and the default is that we only have RS and RH, so it's in percentage. So in that case, the minimum naturally would be 0 and the maximum would be 100. So now it matches what we are looking there, because RS and RH, they both have maximum value of 100 and minimum of 0, so it scales accordingly. So that's what we have default today. This machine didn't yet have the latest software edition. But the other useful thing here is the time scale. So it's by default showing 30 minutes of graph, but you can change it to anything, I think, between 1 minute and multiple hours. So there is no and if you have let's say like a 30 minutes visible and you want to go to all the results, you just go to the history of the display. Did I forget something? No.
No, I think there's everything.
Yeah. Okay, so I'm going back to the dashboard and handing the control back to you.
Yeah. Okay, so now when we have looked all of those, we are ready. Of course, if we are, or when we are in a real life decontamination process, we will check all the necessary things. We have sealed the enclosure properly, and we have everything put on their places and set up.
Like here we have air ventilation ducts, they would be covered and so forth. And also when we leave the area, the door needs to be sealed. So it's a good idea to have duct tape. And when we leave the room, we remember to take the indicator tape with us.
Yes.
Don't forget that in the room, because otherwise it will be spoiled. And we take the personal monitor with us. And we also take all items which are unnecessary for the process itself. For example, we don't leave these paddings or any other equipment in the area which is being treated. Now, one thing which is very important to remember, especially when you are doing real field work, you have to have a protective gear that matches the threat you are countering. So if you are going to decontaminate an ambulance and there is a known risk that that corona patient may have been in that ambulance, of course you need to wear the appropriate protective gear. So for the simplicity of the training, we don't have a protective gear other than for just simple example. But as you saw in the presentation slides, that ambulance picture was taken from real field situation. The ambulance was contaminated with corona. So we were using masks and paper coveralls and other protective gear. So always when you set up things, do it as you are in a contaminated area. So don't expose yourselves unnecessarily. So another good question has been that what about the machines? Do they get contaminated? Well, no, they are in the same area where the vapor is. So they are clean, but after the treatment, it's a good idea to have a wet wipe available, because in the immediate vicinity of the machine, like on the surface of the machine, you may have some microcondensation. You may not see it, but when you touch the machine, you may have a white stain on your finger because of the microcondensation in there. And another practical little hint is that when you remove the bottle after the treatment, or you change the water bottle in, you should look into the bottle holder, because especially if the liquid has been cold, so if you have been storing it in a fridge, for example, it's very cold. So just like when you take a bottle out of a fridge, it may have some bubbles condensing on the surface. So in the same way, the hot hydrogen peroxide vapor coming out of the machine may actually condensate on the surface if the bottle is very cold. So it's a temperature gradient, just like a window in a room. So if you see liquid there on the bottom, then you should have a wet wipe and just dry it off. And wiping the device before removing it from the area is always a good idea.
Yes. Okay.
So when we start the cycle, we have the buttons pause and stop that we can use. So what's the difference, Emma, between the pause and stop?
The pause is made for the need of change the hydrogen peroxide bottle during the decontamination process. So, for example, if we are in a very, very large enclosure and we will run out of hydrogen peroxide, we can just press pause and the decontamination process will be stopped for that while, and you can change the hydrogen peroxide bottle during that, and then just pressing again the pause button, the decontamination process will.
Has it ever happened to you that the bottle has emptied during the process?
Not actually.
Because it's 5.5 hours for 1 liter, so at least we always start with a fresh bottle. Oh, by the way, these bottles are recyclable, so don't throw them away. So they can be refilled. You know, we are not in the inkjet printer business. You can refill these bottles if you have a source of food grade hydrogen peroxide. These can be refilled and recycled, so don't throw them away. This bottle actually costs more than the liquid inside. Okay, so there was a question about what's the use of the catalyst converter. As we mentioned earlier, the catalyst converter, this is used for accelerating the aeration. So when the treatment cycle stops, then based on the parameters that were set right here, the catalyst converter goes on. So we don't actually have we can have it, as I said, a good example is to have it like between 0 and we had the program of whatever. So now we put it on. It's now on the automatic. The cycle was on, so we had it running. So I'm taking it off. Yeah. Okay. So we normally we put it to like 3 to 250, and there's a manual on and off here. Okay. And when we have it on automatically, we just set the range there. So the purpose is to get rid of the hydrogen peroxide after the treatment. And when it goes to our deliverables, the master device, it always comes with a catalytic converter. The extension unit doesn't have it as a default. But whenever you procure a master device, no matter whether it's CR series or M series, it always has a catalytic converter coming with it. So don't worry, you don't have to buy it separately. But if you have a large setup for large volumes, like you have multiple extension units, then you may need multiple catalytic converters as well. But you can add them to the network as many as you want.
Yes. We have a good question there. Vinyak is asking, what is the capacity of each model and the time taken for the same?
Okay, so that's actually a very good question. And there is no simple single answer to that, because the capacity depends on the type of the space, size, and also on the materials. So if we have a theoretical inert room, like a room with metal walls, such a test room, yes, we can do up to 500 cubic meters without problem. And that's what everybody's marketing materials say that they can do, 500,000, you name it, but that's not the real life situation. So our guidance for dimensioning is that have one production unit per starting 100 cubic meters if you have an office room or meeting room or hospital room which has absorbing materials. But if you are in a laboratory type of inert or near inert environment, 200 or even 200 plus cubic meters per unit is okay, because you don't have absorbing surfaces. It also depends on how much time you have. So, for example, in the Korea CDC, we were given certain time limits. So we dimensioned one device per, on average, of 150 cubic meters, and we could do one cycle that was about 600 cubic meter area of 600 cubic meter volume. And that was about 1 hour, 15 minutes each. So we completed it in a very short time. So, so the capacity, the output capacity of the main unit and the extension unit is exactly the same. So it can be said that you double your budget, you triple your output, or even a little bit more. And the old M series, it's master only, or old. It's fit for the purposes where you only need master unit. It's the same capacity as well. The Mini, the VCS20, we call it Mini model. That is designed for very small spaces, maximum of 20 cubic meters, and we don't really mass produce it time being because of the corona. We have hands full with making these full-scale machines. Now, what is the minimum volume? We really don't recommend putting this unit into a volume less than 10 cubic meters, because the output is such dramatic that you may accidentally get condensation before the output limiters and the software functions can reduce it. So I would say that 10 cubic meters is the utmost minimum.
Yes. Okay. Let's go forward with the...
Hey, there is a question from Piotr. If we don't have any windows to observe the test result of color change, what should be the basic setup to be sure of the results? What should be the start treatment time? And many rooms don't allow you to reach 200 ppm due to absorption. What would be the treatment time, for example, 150 ppm? A very good question. I had this situation yesterday when I was doing a training session, and it was a quite small room that we used as a test chamber, and the concentration was building up fast. It went to like 220 ppm very fast, but then it leveled. And the room was highly absorbing. It was made of mostly absorbing materials. Now we got color change on the tapes. We could observe them through a window, so it happened in about 35 minutes, if I remember correct, 40 minutes, something like that. Now, if we don't have the chance to view what's inside, I would say that the rough estimate is that if the room is like a single bed hospital room, I would initially use something like 1 hour. And let's say if the volume is like 30 to 40 cubic meters, I would use maybe 1 hour. If it's something like 70 cubic meters, I would use 1.5 hours. And but if given a chance, I wouldn't try to start with more than 2 hour treatments. Now, if the 150 is the ppm target and we want to get full kill, so the indicator tapes changing color with 150, I would initially use maybe 1.5 hours for a normal hospital room or other room which has volume about 40 or 50 cubic meters, something like that. So this is something that there is no single self-explaining rule, because every room has different kind of materials. But let's say you have a hospital or office. Once you have benchmarked one room, you can quite safely presume that the same dimensioning is fit for the other rooms as well.
Yes. Okay. So when we look for the setup of the device, so when we have everything done, we can press start for the process. And here you will have this confirmation page where you can choose where until to which ppm level will the report be written and the data log end criteria.
Yeah, so the machine is collecting log. I think it's every 5 seconds or every 10 seconds, something like that.
Yes,
changing all
around that.
Yeah.
So we can choose anything between 0 to 50 ppm. For example, now 5 ppm. We can choose if we want to delete the old report from the data log memory after the process. Here you can see again if the cut is selected on and which are the ppm range where the cut will be processing on. Then we can just press start and the device will start to warm up the heat plates.
Yeah, it shows heating right here.
Yes, and we can also see there that the catalytic converter is connected and the external
Yeah,
unit.
we also see we have one extension unit here.
Yes. And now on this phase when the device is warming up the heat plates and starting the process, it will take around few minutes. Is it 3 to 5?
3 to 4 minutes, and when it's ready to start, it gives you a warning signal. But I suggest that we don't go that far here in the studio because we may have residual hydrogen peroxide in the evaporator chamber. So I guess we just stop now. And when the program stops, the machine always runs a cooling process after that. So you can hear the fan running right now, and that is to make sure that the evaporator cell gets as empty as possible, and it's also to prevent any overheating after the system has been stopped.
Yes. When the decontamination process has been done, we can go to the report from the left side, from the left corner, and here we can save the data from the device. It can be done in few different ways. For this printing option is not available yet. It's still under developing, but it will be soon coming to use. But we can take the data from the device via USB memory or generating the reports to this website where it will be saved to as an Excel or PDF.
Yeah, so
file.
you can download it in HTML format or Excel format from the device. Oh, we have a question related to previous part of discussion that if there is no window for observing what's happening inside, why don't we use an IP camera to watch the indicator tapes? Yes, that's common practice. It's, if there is no other way to observe what happens inside, use of IP camera is a good idea.
Yes, that's true.
And there's an audio question coming so from the audience. So, Tuomas, please.
So Chris Santosa asks, our needs is to decontaminate protecting clothes and hazmats made from fabrics and polymer fabrics. Do you have any research on this? What is the decontamination capacity for this in terms of set of protecting clothes?
Okay, so the question about what about the time and procedure for cleaning other disposables than just the masks. Yes, this is actually something that our military is actively investigating right now. What are the suggested treatment times and capacities, but based on just on the designs that we have been evaluating and what we have been doing some calculations of our own, if we have a system which has a twin line 20-foot container as basic decontamination chambers, for example, surgical jackets, the daily capacity can be up to 10,000. So it depends on how many shifts are used, and also it can be parallelized. So you can have multiple processes in parallel. So for a system of reasonable surface area footprint, it's possible to decontaminate tens of thousands of masks per day, or several thousands of surgical jackets and aprons and materials like that. So you can, out of these disposable medical materials, you can decontaminate pretty much everything. Now the good thing about hydrogen peroxide vapor is that it doesn't damage like paper coveralls or like a paper aprons. It doesn't damage the masks. So it has already been concluded that not even the plastic ribbons, they have no effect. They just they can survive dozens of treatments. Now, of course, you don't recycle something which is visibly dirty. So if the mask is dirty, it goes to garbage. But if it's visually clean, it can be recycled. But then when it comes to syringes, surgical knives, and all normally disposable objects like breathing masks, inhaling aids, they can all be recycled by simply first washing the visible dirt away. So just regular washing with mild temperature, with normal like a low temperature dishwasher is okay. And of course that doesn't kill the bacteria, but after you have dried the items, you can use hydrogen peroxide vapor for the final decontamination. There's a question from Pepe that what about ambulances and planes of same models? Can they save the parameters? Answer is yes. Now, the only issue is that with aircraft, for example, you can have leather seats or canvas fabric seats. So that has a difference on how much is absorbing and how much time you need. But if the configuration is exactly the same, so we have same material, same fabrics, like the good thing about here in Finland is that it seems that one ambulance company has more or less monopoly, and so far most of the actually all the ambulances that I've been dealing with, they have been of exactly same manufacturer and same model. So yes, you can do preset programs, and you can also make variables for different temperatures and starting humidities, and but it's not really that difficult, because this is the miracle thing that we have, the Vaisala sensor. So even if your parameters are too aggressive, you can't do any damage because the RS limit is protecting your target.
Yes. Okay. So we can generate the report by pressing here and choosing the format for the report, for example, Excel table. You can see on the corner there is this text saving report. You should wait until that has been disappeared. Then the report has been saved. If you are saving the data with USB memory, you just add the USB memory stick to this USB slot on the device. Actually, it's on the master device over here. You can see it. Just add the memory there. Then from the setting up panel, just press the USB and select the report format, and then it will be saved to your to your USB memory, and you will have the data from the device.
So I guess the last thing to do is rinsing the system. So
Yes.
if you are going to reuse the machine, let's say same day or next day, the rinsing is not that much important. But if you don't know when it's going to be used next time, so what you do is you change the bottle. So you remove the hydrogen peroxide bottle, and now you have to be careful because you may have some droplets on these hoses. So we take the hydrogen peroxide bottle away, and we would have a water bottle available. And it's actually a good idea to change this cork unit and hose unit to the water bottle, because then you get the rinsing of these lines as well. And you put it back, and now we have the water bottle in. Okay, and can you show just how do we do the rinsing now?
Yes. Now we will go to the set page back, and here you can see, as you remember, the circulate button. We will press there, and the device will do the circulation.
And we can see the bubbles moving in the pipes.
Yes.
And the same happens in the extension unit. So naturally, if you have extension units, you need to have a corresponding number of water bottles that you can put in place. Now, you can also use some alternative bottles that fit for the purpose, because this cork doesn't need to be tight as long as it's submerged into the water liquid. And for this particular purpose, it's a good idea to use distilled water, because normal regular tap water, it has impurities and it has residuals. So battery water, distilled water, that's recommended for this. But if you don't have battery water available, then regular tap water will do.
Yes.
It's just a recommendation. So we have 2 more questions. Miguel is asking H2O2 transportation. Now, 50% hydrogen peroxide, the transport rules are UN 2014. So you have to study those regulations, but yes, you can transport 50% liquid without any special arrangements. And of course, if the weather is very hot, I would recommend using, let's say, like a freezer box, not freezer box, but like one of those styrofoam picnic boxes that you keep your beer cool when you go out for the picnic. And then there was another question about whether this will be available. Yes, this will be available. We will post a link on our website, so you can watch this later. And one more question: FDA approval applied for. CE approval, yes, we do have CE approval. And any spare parts required? Well, of course, you may have a broken consumables, so of course we provide spare parts for these. But otherwise, this unit is quite maintenance free, so we offer 1 year support and maintenance program at a time. So when you subscribe to the annual support and maintenance, it means that you have a new device all the time. So the support and maintenance program means that once a year your machine is factory refurbished, and it's also like a eternal warranty. So as long as you subscribe to the maintenance program, whatever breaks in your machine or whatever wears out, it will be fixed. And once a year, it has full checkup, calibration, and replacement of any worn parts. The Vaisala sensor recommended calibration interval is 1 year, and the evaporator unit, even when you use a very high quality hydrogen peroxide, you always have some residuals from the stabilizers. So it's also recommended that at least once a year is performance checked, and the certain elements may be replaced, and that's part of the maintenance program. Depending on the quality of hydrogen peroxide, This maintenance interval is somewhere between 250 and 500 hours on full power, which is quite substantial. So most customers don't reach that within a year. And as said, it can be actually much longer when high quality hydrogen peroxide is being used. Okay, so thank you. Thank you. Oh, well, one more question's coming. So Satwesh is asking, where can we buy chemical indicators and bioindicators? Well, we ship each device with one reel of chemical tape. Now this is 3M Compli, a brand. You can get it anywhere. This is not regulated product by any means. Bioindicators, we don't sell them. However, you can order them from various sources. The ones that we mostly use are from French company Mesalabs. We are using their bioindicators, and they come with a full incubation tubes and liquids and everything. So all you need is an incubator cabinet for analyzing those results. All right. So thanks again. And thanks Turkka, thanks Emma.
Thank
We
you.
say goodbye for everybody. And this will be available as a recording later on. Thank you.
Thank you.